slope-intercept form is y equals mx plus b. And the m is just standing in the place of a number. There will be a number there, and whatever that number is the slope. And we learned earlier that slope is rise over run. The b stands for the y-intercept, and we talked about intercepts in a previous lesson. So if I give you a slope of 4 and a y-intercept of -3, the equation will look like y equals 4x minus 3. I can see that the 4 is the slope, and I can see that the -3 is the y-intercept. Here are a couple of other examples, some more examples. Look at number 2. The slope is -3, and the y-intercept is 7. So that equation would be y equals -3x plus 7. And this last one is a little bit challenging. We have to think about what type of lines have a slope of 0. And hopefully you remember that a horizontal line will have a slope of 0. And if that line crosses the y-axis at +5, then the equation of the line would be y equals 5. It makes sense because if I plug in a slope of 0 right here for x, 0 times x is 0, and I'm basically just left with that positive 5. So the equation would be y equals 5. On this page, you'll be able to see what happens to a line as I change the slope, which is the m value, and what happens when I change the y-intercept, which is the b value. So if I click on this plus here for the y-intercept, notice that the graph moves up. Now it's crossing at 2, now it's crossing at 3, now it's crossing at 4 and 5. If I change back the other way, now it's crossing at -1 and -2 and -3 and so on. Let me go ahead and take this all the way back to where it started at the origin, so it's crossing at 0, 0. Now if I change the m, which is the slope, and make it bigger, you'll notice that the line is getting steeper. And we learned in that lesson on slope that slope is the steepness of a line. So if I change my intercept to +2, you'll see the equation of the line is at +2, there's my intercept, and my slope is 7. We want our slope to be a fraction, so I could also say 7/1. I go up 7 and then right 1. If I decrease this slope, now it's 3/1, 2/1, and so on, it will go to the negative side, and now I'm getting a negative graph. So this is how we can change a line by changing the slope and the y-intercept. On your page, you'll see some graph paper, and this equation, we're going to try and write it, and we're going to use the slope, which is m, and the y-intercept, which is b. Let's start with the slope. I'm going to count how much I rose and how much I ran. I see the distance here is 1, 2, 3, and I ran once. So my slope is 3/1. The y-intercept is this little smiley face right here, and I see that that is at 0, -2. So if I'm going to write this equation, I have all the information that I need. Y equals the slope, which is 3, and the intercept, which is negative 2. This is the graph of y equals 3x minus 2. And go back and write in that intercept. Forgot to write it over there. So here's another graph. And again, I'm going to need the slope, and I'm going to need the y-intercept. What I notice about this graph, if I put my finger on the left side of the line and slide, I notice that my hand is going down, which tells me that the slope is going to be negative. Let's see, there's a 1 there, and 1, 2, 3, 4. And slope is rise over run, so this slope must be negative 1 over 4. Now I need the y-intercept. That's this dot right here, and I can see that that dot is at 0, 3. So I have all the information I need to write an equation. Y equals negative 1/4 x plus 3. I would like you to complete this one on your own, and you can use the example from the first page, the horizontal line, so think about what that means for the slope, and think about what the y-intercept is, and I'd like you to write the equation for this horizontal line. So now we're going to try to graph a few using what we have learned. Here is my slope, my rise over run. And this is my y-intercept. This tells me that the y-intercept is 0, 3. In your notes, there's a place for you to write down that the y-intercept is your starting point. This is where we're going to begin our graph. Once we have our starting point, we're going to use our slope as directions. So let's go to our starting point, 0, 3. From there, I'm going to follow my rise over run. I'm going to rise 1 and run 2. Rise 1, run 2. Rise 1, run 2. I'm going to do that all the way across my graph paper, and I'm going to connect those dots, putting arrowhead at the end to show that this graph goes on forever in that direction. Well, my graph goes on forever in the other direction as well. So the opposite of rise 1 and right 2 would be down 1, left 2. Down 1, left 2. Down 1, left 2. And you should be able to see that these points that I'm adding are the continuation of that same line. I'll put an arrowhead at that end to show that my graph goes on forever in both directions. Now if I move this red square, see if I can do that. Let's see if our graph that we just made matches the answer. And it certainly does. It goes through at 0, 3, and I am rising 1 and running 2, just like my slope asked me to do. Those were the directions my slope gave me. On this one, I would like you to try to graph yourself. Here are my directions. Notice that it's going to be a negative graph. That means it's going to be going down from left to right. And here is my y-intercept. So my starting point is at 0, -1, and my directions are to go down 3, right 4, over and over again, as many times as I can fit on that graph paper on my note page. So those first examples were nice to do because they were already ready to graph. But sometimes equations are not ready to graph. This is slope-intercept form, y equals mx plus b. If I look at this equation, -5x plus 3y equals 12, I notice that it doesn't look like that first equation written in pink. I need the y to be by itself, and I need the x to come next. So this is why we spent so much time learning how to solve equations. I need the y by itself. So I start by circling the y and its coefficient, and I'm going to get rid of that negative 5x by adding 5x on both sides. This makes this turn into a zero pair. It's gone from the left side. I am left with 3y equals. Now, am I allowed to combine these two pieces? No, because they are not like terms. I cannot combine 12 and 5x. And if I look at my original equation, what I'm trying to get to, I need the 5x first, and I need the 12 at the end. Now, should this be a plus 12 or a minus 12? Well, this original 12 was positive, so I'm going to put a plus sign in there. And my final step to get the y by itself is to divide every piece by 3. I've got a coefficient of 1, and 1y is the same thing as just y. I've got a slope that is a fraction, which is what I want. I know you guys could turn that into 1 and 2/5, but that's not going to help me graph. I need a rise and a run. This tells me that I will be rising 5 and running 3. And my final part here, 12 divided by 3 is 4. Now I'm going to check my two steps over here. Is the y by itself? Yes. Does the x come next? Yes. This equation is ready to graph. My slope is 5 over 3. And my y-intercept is 0, 4. So I can come over to my graph and put a point at 0, 4. That is my starting point. And my slope says rise 5, 1, 2, 3, 4, 5, and run 3, 1, 2, 3. To find the other half of the line, I'm going to do the opposite. I'm going to go down 5, left 3. Down 5, left 3. And I'm going to connect those points, putting an arrowhead at both ends, showing that my graph goes on forever in both directions. Graphing is important in real-life situations like this. A car rental is $50 plus 15 cents per mile. Well, I'm going to get charged 15 cents for every mile that I go. On top of that, I have to pay 50 bucks. I only have to pay that $50 one time, so that's why the 50 is by itself. But the 15 cents happens for every mile. So depending on how many miles I go, that will determine how much I pay to rent that car. Your uncle weighs 260 pounds, and he's losing 2 pounds each month. So he's starting at 260, and he's losing, that sounds like subtract, 2 pounds every month. So how much he loses depends on how many months we're talking about. Now, if I wanted to write this equation in slope-intercept form, I would just move the pieces so that the x comes next and the 260 is at the end. Why is it plus 260? Because this was a positive 260. And I'd like you to try this number 3 on your own. Please try and write an equation that shows the relationship between a store that charges you $8 to be a member and then $4.50 for each video that you rent. Your next big project is called Graphing for Dummies, and I can't wait for you guys to get started on it.